Hello and welcome. In this video, I want to explain deep learning from a practical and realistic point of view. If you've already watched my previous videos on artificial intelligence and machine learning, you know I like to keep things clear and simple, without marketing hype or overcomplicated explanations. My goal here is to help you understand what deep learning is, how it's used, and what makes it different from other AI technologies. Let's start from something basic. Deep learning is not separate from AI or machine learning. It's actually a subset of machine learning. That means every deep learning system is a machine learning system. But not every machine learning system uses deep learning. So, what makes a deep learning special? It's based on a concept called artificial neural network. Mathematical models inspired by how our human brains work. At least, of course, in a very simplified way. These networks consist of layers of neurons that are connected to each other, and the idea is that each layer of the network learns something more detailed from the data. The deeper the network, meaning the more layers, the more abstract or complex patterns it can learn. That's where the term deep learning comes from. Before we proceed, if you find this content helpful, please like and subscribe. Your support helps grow our community and signals to YouTube that this channel provides valuable information. I very appreciate your help in sharing knowledge. So, in traditional machine learning, we often need to manually select features. For example, if we want to build a model to recognize cars and images, we might have to write code that looks for wheels, lights, edges, and other features. But in case of deep learning, the neural network can automatically learn these features from the raw data. That's why deep learning has been so successful in areas like image recognition, speech processing, and natural language understanding. Let me give you a simple real-world example. If you use voice assistants like Alexa, Siri, Google Assistant, the voice recognition part is powered by deep learning. These systems use a deep neural network to recognize what you say and then map it to possible meaning. Or, if you use Netflix, YouTube, or TikTok, deep learning helps decide what videos to recommend to you based on your behavior. One more example is self-driving cars. They rely heavily on deep learning models to process camera images, radar signals, and LiDAR data to detect pedestrians, lanes, and traffic signs. This is a case where traditional rule-based systems don't work well, just because environment is too complex. But deep learning can process huge amounts of data quickly and find patterns that humans may not even notice. Technically, deep learning models are very data hungry. They require huge data sets and a lot of computing power to train properly. That's why deep learning only became truly practical in the last decade, when we got access to cloud computing, power GPUs, and big data. Now, many cloud providers like AWS, Azure, and Google Cloud offer built-in services for deep learning, such as SageMaker, Vertex AI, or Azure Machine Learning, that help teams train and deploy neural networks more easily. If we are talking about open source, we can recall models deep learning software from Google. But even with these tools, you still need to understand the basics, especially if you are responsible for integration, cost control, or making decisions about what kind of AI your business needs. Let's talk for a moment about limitations. Deep learning is very powerful, but it is also not magic. It works best when the problem has a lot of training data and when the goal can be clearly defined, like classifying an image, translation sentences, or detection anomalies. But deep learning models can be expensive to train, hard to interpret, and very sensitive to biased data. They also don't understand meaning in the way humans do. A deep learning model can generate a full paragraph of text or a realistic image, but it doesn't understand what it's saying or drawing. It's just prediction, the most likely next output based on patterns it has seen during training. That's why explainability is still a challenge. If your business needs full traceability and transparency, like in banking, healthcare, or government, you might need extra tools or methods to monitor deep learning models. This is something that's been actively researched right now. Also, deep learning is not always the best tools for the job. Sometimes a simple machine learning model like decision trees or linear regression is fully enough and much cheaper to use. That's why in real world IT and cloud project, we always start by evaluation the problem first, not the tool. We don't use deep learning just because it sounds advanced. We use it when it's the right choice for the data and the business goal. And I agree with many experts like Andrew Young, who says we should look at AI and deep learning as tools. Powerful tools, of course, but still tools. They don't replace people, they support people. They help us automate, scale, and improve things. But they don't think or understand in the way that humans do. At least not today. So, what is my practical view? Deep learning is one of the most important technologies we have today. It powers a lot of modern AI applications, from speech recognition to recommendation engines. But to use it well, you need to know its strengths, limits, and requirements. It's not for every problem, and it's not free to use at scale. But when you match it to the right use cases and support it with good data, smart design, and proper cloud tools, deep learning can deliver real results. Thank you for watching and see you next time.